All right, so today what we're going to do for this lesson, this would be module number 7, and we're going to have a look at their intro to the rates. We would call this reaction kinetics. So this is basically pages 20, 21, and 22, so 3 pages worth, but it's really not too tricky. This is really the second half of our whole unit, and we've already looked at the first part, which had to do with enthalpy, and now the second part just has to do with how to speed things up and how you explain that at the molecular level. Okay, so this module is just going to be about how do you calculate the rate of a reaction. What are the different ways you could do this? To the next lesson will be about potential energy diagrams. That may be the only one that's going to be a little tricky. And then after that is just really finishing up the unit. So we're getting quite close to the end of this unit, and then we'll move on to new stuff in unit number 4. Okay, so I hope everybody's still doing well. And this one would have been a fun one to do in the lab. But instead what I'll do is I'll post a quick little video attached to this assignment module, and if you could watch that, that would be good. In the video, he shows you what it would look like, the reaction where you add magnesium into the hydrochloric acid. Now in the lab, we would have done this using a strip of magnesium, and we would have balled it all up to have a small little section of metal that we would then add to our hydrochloric acid. And the whole point of this would be to compare the rates of the reaction of the magnesium metal versus the zinc metal. So what I've got in the bottom left-hand corner of this window here is what those metals look like when we would take them out of the prep room and have them ready for our lab. So the zinc's the one at the very top, if you can see that right underneath me right there. That's what the zinc looks like. It's called mossy zinc, and you can see that the surface area of it, it's a little bit different than what the magnesium comes in. Now the magnesium comes in a big ribbon strip, and you've seen that before. We've done that where you take magnesium, you would have burned it in oxygen in the Bunsen burner, and it has a big white flame. You would have done that a couple of times, probably in grade 9 and grade 10, and I'm sure in grade 11 as well. This case, we would try to take a small snippet of the magnesium and roll it all up, okay? We would try to get it to a small coiled strip of magnesium. Can you see that right here? Okay, and we would try to put both of them in at the same time and compare the rates. All right, I already filled in the balanced chemical equation. That would be obvious. You're going to have a single displacement reaction, and you're producing hydrogen gas. So this would have been another great example where you could test the gas and you can hear this squeaky pop. The one thing I like about the video that I'm going to post is that the science teacher in that video shows you all the measurements you could take if you needed to quantify that rate of reaction, okay? Because at some point you have to be able to compare it, and you need some quantitative data. So what could you do to measure the rate and compare the two to see which one was going to be faster? You could do a whole number of different things, okay? And this is what this whole note basically goes through. Okay, so for the first one, the first observation table just says, well, what's the difference between the two? The video that I'm going to let you watch is the magnesium. If you want to randomly search another video to show what it looks like with the zinc and the hydrochloric acid, go ahead. You'll just notice that the rate of the reaction is a little bit slower. But again, if you're just going to randomly check out a video, just make sure that you're, having a look at the concentration of the hydrochloric acid, because you may have one that's more concentrated, and then you may say, oh, well, it looks like the zinc's going to go at a faster rate. And that's not going to be the case. The magnesium will be faster, okay? So in this controlled experiment, the only thing we're going to change is the type of metal, and we're going to try to keep everything else the same. So in this case, both of the acid concentrations for your hydrochloric acid are 3 molar, and you use the same volume of the acid in the same container. We've tried to get the magnesium rolled up to be somewhat similar to the magnesium because it's the surface area that's the one that you can't really control. Okay? All right, so what do? You need to be able to measure the rate of a reaction, and it could be absolutely anything that you calculate in order to get the rate. Basically, you want the change in the amount or concentration of a substance given a unit time, per time. Okay, so this unit again, or this lesson, is all just about calculating the rate of the reaction and all of the different ways that you could do it. So the first thing you could do would be, what if you've got the decrease in the mass? So what if you take a measurement of the mass before and then the mass after, change in mass, divided by the length of time. That'll give you a rate measurement. And in the video, it's nice where the teacher does all those measurements ahead of time so that you could imagine timing it. Great, you put the magnesium in the hydrochloric acid, you've got an initial time, you've got a final time, you've got the change in the mass because you did an initial mass and a final mass, and you could get a measurement for the rate that way. All right, does that make sense? That's one way you could do it. What's another way you could actually calculate the rate of the reaction? What if you did the rate in the decrease of the concentration of the hydrochloric acid? Well, that makes sense. How would you do that? Okay. Well, you could do a measurement calculation using a titration. Now, this is what you may have seen in grade 11, right? You've heard about this before, but how can you figure out the concentration of that hydrochloric acid over time? You could take a little sample out. You could do a titration where you're taking a base and you're neutralizing the acid, and the amount of base that you need in order to neutralize the acid, you can use to back calculate what the concentration of the hydrochloric acid is. Now, that's what you do in a titration. You could do the same thing here. Okay, that's a little tricky. You also know that the change in hydrochloric acid is going to be something you could measure with the pH, right? So what if the concentration of the hydrochloric acid changes over time, which it will as it gets used up, and becomes more alkaline, less acidic? You could get a measurement of the increase in pH over time, right? And how do you do that? Well, stick in a pH meter. You could totally do that. And the teacher video, he shows you what you could do. So you've got an initial pH, you've got a final pH, divided by the time for the reaction to go, and now you've got a measurement that you could use to be able to quantify the rate of the reaction. The next one's kind of neat. Have you seen that downward displacement measurement where you do? You can see in the picture below there, you've got your graduated cylinder. Turn it upside down. You've got quantifying marks on it, and that displacement function of the gas building up, because of course you're getting the hydrogen gas, it can flow up. Oh, I don't want to make it bigger. Flow up, over, and up into our graduated cylinder, and you could get a measurement of, well, increase in volume per time. Also know that you're going to be creating a gas which is going to increase the pressure. So what if you want to measure the pressure? You could do that. Increase in kilopascals per time. And the last one here would be completion of the reaction in open container on a balance. And so if you did that, you can get a mass change. You can see that. And so you've got your decrease in mass over time. Again, another way, you could just measure the rate of a chemical reaction. What if you wanted to measure the rate and increase in temperature? And if we did this in the lab, you'd see that it's very exothermic, okay? So it's going to get really hot to the touch, and we would, set our test tube either in a beaker, or we'd set our test tube in a test tube rack. But what if you wanted to measure the temperature change over time? Yep, you could do that too, right? And it would, the faster it gets warmer, the faster the rate of the reaction would be. So you could put a thermometer in, and you could get an increase in degrees Celsius also over time. Okay, so basically this lesson was just all about how could you measure the rate of a chemical reaction, and there are lots of different ways you can do it, especially when you're using an acid and an active metal, because you're going to have so many different variables that are going to change. Okay. The last little table at the top here of the next page, on page number 21, just got you thinking again about, well, what was our independent variable? If we did this lab, that's the type of metal. The dependent variable, what rate? That's the rate of reaction. Could be anything you want. What are some controls that we used in our experiment? And then what was a variable that was difficult to control? And again, if you can see the metals down below here, obviously it was the surface area. And we know that the atoms that are on the surface are going to be doing the reacting, right? We're going to be looking at explaining at the molecular level in another module. So I just want you to remember thinking about that, yeah, are we highly controlled here? Well, as controlled as we could possibly be, just taking into fact that the surface area is going to be different. Okay, so there's some measurement calculations to work through. Shouldn't take you too long to do those. You can just remember to use your unit analysis, figure out what unit you need. You need a rate, you need something over time, and depending on what it happens to be, you're all pretty good at doing these sorts of calculations. So try the example 2 questions here, and then there's some rate problems on the next page. Just a quick reminder though that an S means is the short form for seconds. Many of us try to just go short form SEC, but that's not actually correct. It's actually just an S, minutes, and then an H for hour. All right, so give those a try, and the next lesson will be on potential energy diagrams.